Here are solutions to homework set number 12 for ECE 111. This homework set looks at using complex numbers. Now, electrical computer engineers use complex numbers extensively. Anytime you're dealing with sine waves, it's actually a whole lot easier if you do use complex numbers. Basically, for a sine wave, you have sine and cosine. Complex numbers gives you those 2 degrees of freedom to represent sine and cosine. So again, we can live and breathe complex numbers. Likewise, I highly recommend that you get a calculator that can handle complex numbers. I like HP calculators. Back when I was in college, we used to have races, HPs versus the world, and HPs will dust anyone else. They are really, really fast. And in my opinion, HPs are worth 10 points on a test. HPs are really quick. They can crunch through complex number arithmetic very easily. Time matters. On a test, it's kind of a race to the end. A calculator that quickly gives you the answer is worth points. HPs also give you the right answer. That too is worth points. So again, I would highly recommend that you get familiar with an HP calculator. They do have a learning curve. So don't learn how to use them on a test. That's kind of what 111's for. Learn how to use an HP calculator in 111, so by the time you get to circuits 1, circuits 2, you're familiar with them. On this homework set, you could use Matlab if you wanted, but really just solving one equation, one unknown. Calculators work just as well. For this homework, I'm going to use both methods. So the first problem is given a complex number, 3 minus j6, represent it in rectangular and polar form. In Matlab, I input the number as 3 minus j times 6. What I can also do is I can also say 3 minus 6i. Matlab will accept that as well. To convert to polar form, I take the magnitude, that's the radius. To find the angle, that's the Matlab command, angle. Matlab will give you radians. Kind of rule of thumb, anything English is wrong. So converting radians to degrees, I have to multiply by the conversion, 180 over pi. So that's minus 63. So 3 minus j6 is also equal to 6.7 at minus 63 degrees. Now I can do the same thing with an HP calculator. Bring that up. So with an HP calculator, this is an HP prime. It's the one that's still in production. Basically, the calculator that I really love, in my opinion, the best calculator ever made, is the HP42. That's out of production. To use the prime, again, this is a little bit different. It uses RPN notation. So to add two numbers, notice there's no equals. Well, to get to RPN mode, I need to go Shift, Settings, Entry, RPN. That's an RPN mode. That uses reverse Polish notation. So now to add, I would do something like 5, enter 3. This uses a stack. I've got 5 and 3 on the stack. I can now add them. If I want to take 8, multiply by 7, I get the number 7. That pushes 8 and 7 on the stack. Multiply to divide by 4. Hit the number 5. 56 over 4, divide. So the HPs are all about stacks. To input a complex number, there's this I. So if I do 3i negative 6, there's the number. Let's push that on the stack. So there's 3 minus 6i. To convert to polar form, that's this guy right here. That is 6.7 at minus 63 degrees. And converting back. So that's inputting that number. Minus 7 minus j2. That'd be 7 negative I2 negative. Convert to polar form. Oops. Push that on the stack. Shift to polar form. That's 7.28 at minus 164 degrees. Or in Matlab, R is the absolute value. The angle is angle converted to degrees. So that's inputting a complex number. I can do that in polar form as well. If I have a polar form converted to rectangular, the angle is e to the j theta. So you just do 8 times e to the j 147 degrees. Again, Matlab uses radians, so I have to convert degrees to radians and to get the answer. I can also do it as cosine and sine. the real part is cosine, the complex part is sine, or the HP prime, what I can do, let's clear everything out. Let's do 8 at an angle of 147 degrees. Push that on the stack and convert back. So that's minus 6.7 plus j 4.3. For 12 at minus 85 degrees in Matlab, or the HP calculator, we'll do 12 at an angle of negative 85 degrees. Push that on the stack and convert back to rectangular. 1.04 minus j 11.95. So with complex numbers, I can represent the numbers in rectangular form or polar form. They're both perfectly valid. When you add, rectangular form is a lot easier. You just add the real parts and then add the complex parts. So in Matlab, I could do that. To add these numbers, I could say let's input the first number, second number, third number, then add them all up. I get 2 plus j9. Or I could do it all at once. I could have 6 plus j8 plus 7 minus j8 plus 3 minus j7, get the same answer. On an HP prime, the way I would do that is, let's do 6, I8. Now again, I use the stack. I push that number on the stack. To add the second one, I have to first set up the stack. Do negative 7, I8. I've got those two numbers on the stack. I can add them. 3 minus j7, 3i negative 7, add, I get 2 plus j9. I can do that in polar form. So this is where the calculator is actually a lot easier. What this means is 4 times e to the j 84 degrees, converting to radians, 7 times e to the j minus 62 degrees, 9 e to the j 85 degrees, add them all up, I get an answer. I can do that in one line in Matlab, or with an HP prime. I take the first number, 4 at an angle of 84 degrees, push that on the stack, 7 at an angle of negative 62 degrees, add those together, 9 at an angle of 85 degrees, add those together, it's 8.11 at minus 56 degrees, or in rectangular form, 4.88 plus j 6.76. So there you kind of see the HPs are really good at adding, subtracting, multiplying, dividing complex numbers. Another example. Now this is kind of where the HPs really shine. This is a real pain on a TI calculator or a Casio. Really easy on an HP. In Matlab, it's also really easy. Just type it the way you see it, and you get minus 4.5 minus j13. On an HP prime, I'll take the first number, 6, I8, push that on the stack. Now multiply by negative 7, I8. These two numbers multiply. Then divide by 3 minus j7. 3i negative 7, divide. There's your answer. It's a little bit backwards, a little bit weird notation. Once you get used to it, it's really, really fast. Second example. In Matlab, I would type it almost the way you see it, using parentheses, so I get the right order. Kind of a sidelight. If I took out this parentheses, it would actually do 6 plus j8 divided by 7. Take that answer, add it to j8. Matlab interprets it left to right. Adding parentheses never hurts. On an HP calculator, that would be, clear this out, take the first one, 6 plus j8, 6i8, push that on the stack, minus 7, I8, divide. Now take this ratio, 9, I6, push that on the stack, 0, I, negative 7, and kind of notice I now have three things on the stack. Take the ratio, that's this solution. The top one, z, is that solution. Add these together. Now multiply. -2 I6, push that on the stack, 8 I9, take the ratio, take that ratio, multiply. And there's your answer. And pretty easy with an HP. Really tough with a Casio or TI calculator. I can also do other operations with complex numbers. In Matlab, e to a complex number is a complex number. The log of a complex number is a complex number. Complex number raised to a complex number is a complex number. Easy with an HPL also. I just take 3i7 to e to the x, that's right here, 15.14 plus j 13.1, -9 I9, take the log, right there, 2.54 plus j 3.5, and 4 plus j5, 4. And the last one, this button, x to the y, is actually y to the x. I got that backwards. So the first one, this is going to be the first number I enter. 4, I5. Push that on the stack, that's y. The second one, 5i minus 2. 5i negative 2. So y to the x is right here. That's y to the x. Is 46,000 plus j 44,000. So on the actual HP calculators that you buy, this key is correct. It's just in this app they messed up that key. But anyway, I can do complex operations just fine. Partial fractions. I can do partial fractions with complex numbers as well. So if I have this, I know what the answer is going to look like. It's going to be something over x plus 9 plus j4, something over x plus 9 minus j4, and something over x plus 9. To evaluate, to find a, what I do is use the cover-up method. I cover up this term, evaluate at -9 minus j4, and I get an answer. That's a. To find the second term, I cover up this term, analyze at -9 plus j4, I get b. And finally, for the third term, I cover up this guy, analyze at x equals -9, I get the third one. So here's your answer. I could also do that with an HP calculator. This is a typical test question. It's going to take a little bit of time, but being able to do complex numbers makes it a whole lot easier. Got a bunch of complex operations to execute. HPs will do this a lot faster than a TI. Similarly, if I have complex numbers in the numerator, doesn't really matter. Using the cover-up method, for the first term, I plug in x equals 0, cover up this guy, analyze it, I get a. For the second term, cover up -4, analyze at x equals -4, get the second term, and so on for the rest. So here's the partial fraction expansion. Okay, so that's some operations with complex numbers. And this homework set really isn't using Matlab. You could just use a calculator. That's when you're solving one equation, one unknown. Matlab isn't really necessary. An HP calculator would work. Other calculators sort of work. Kind of my recommendation again, for tests, when you don't have access to Matlab, get a calculator that can handle complex numbers. You should be able to solve these problems pretty easily by the time you get to Circuits 1, Circuits 2. When you start solving n equations for n unknowns with complex numbers, that's when you really need Matlab. That'll be next week's homework. But for this week, it's just getting familiar with complex numbers. That's homework set number 12 for ECE 111.